Given this square matrix B, find the inverse. Remember, if B is a square matrix, then its inverse is also a square matrix. The first thing we should probably do is create an augmented matrix out of this. So we'll have B on the left-hand side with its coefficients, and on the right-hand side, we'll have a 3 by 3 identity matrix. As always, the first step to Gauss-Jordan reduction is to get a 1 in the top left corner. Luckily for us, we already have a 1 there, so now we can start looking to get zeros underneath it. So the first thing we should probably do is get rid of that 2. What we're going to do is multiply the first row by -2 and then add it to the second row. Next, we should probably get rid of that -3. So what we're going to do is multiply row 1 by 3 and then add it to row 3. Now we're very close to row echelon form. What I'm going to do is take row 2 and multiply it by -1. This will give me a diagonal of 1s. Our next goal is to get zeros in the upper right triangle. The first thing we're going to start with is that 2. I'm going to multiply row 2 by -2 and then add it to row 1. This will cancel out that 2 in the second column. Following the same procedure, I'm going to cancel out that -4 in the second row and that 11 in the first row. This leaves us with an augmented matrix where the left-hand side is a 3 by 3 identity matrix and the right-hand side is some product of Gaussian elimination. The right hand is also now the inverse of our original matrix. So B inverse is equal to this matrix. In order to check that B inverse is actually the inverse of B, we have to multiply B times B inverse and hope that it equals the identity matrix. Then we have to multiply B inverse by B and also hope that it turns into the identity matrix. If either of these fail, B inverse is not actually the inverse of B.